When the RMS Titanic sailed across the Atlantic in 1912, it was more than just a ship, it was a floating technological system. Please subscribe. Hidden beneath its luxurious interiors and powerful engines was a complex electrical network that supplied energy throughout the entire vessel. From the bright lights in first-class halls to the operation of communication equipment and machinery, electricity played a vital role in daily life on board. The process began deep inside the ship's engineering sections, where massive steam-powered generators produced electrical energy. These generators were connected to the same steam system that powered Titanic's engines. Coal burned in the boilers created steam under high pressure, and part of that steam was directed to electrical generating equipment. As the generators rotated, they produced electricity continuously. This electrical current then entered Titanic's distribution system, a network of cables, switchboards, and control panels that carried power across the ship. Considering the enormous size of Titanic, delivering electricity efficiently to every section required careful planning and engineering. The ship was divided into multiple zones, each requiring different levels of power. Lighting systems, motors, communication equipment, pumps, ventilation fans, and elevators all depended on electricity. The distribution network ensured that these systems received a stable supply of energy throughout the voyage. One of the most visible uses of electricity was lighting. Thousands of electric lamps illuminated corridors, dining rooms, staircases, cabins, and work areas. At the time, this level of electric lighting was considered modern and advanced. It gave Titanic a bright and sophisticated atmosphere, especially during nighttime operations. But electricity on Titanic was not only about comfort, it was also essential for communication. The wireless room depended on electrical equipment to send and receive radio signals across long distances. This system connected the ship to the outside world and played an important role during the voyage. Ventilation systems also relied on electricity. Large electric fans circulated air through enclosed spaces, helping maintain airflow within different parts of the ship. Pumps powered by electricity moved water where needed, supporting both operational and safety systems. To control this vast network, Titanic used central switchboards. These switchboards acted as distribution centers, directing electricity to different areas and allowing engineers to monitor performance. If a problem occurred in one section, power could be adjusted or isolated to protect the rest of the system. Reliability was extremely important. Because so many functions depended on electricity, the system had to operate continuously. Multiple generators provided backup capability, ensuring that if one generator experienced problems, others could continue supplying power. This redundancy improved stability and reflected advanced engineering practices for the era. The cables themselves were carefully routed throughout the ship. They passed behind walls, beneath floors, and through engineering spaces, connecting distant sections of the vessel into one integrated electrical network. For passengers, most of this system remained invisible, hidden behind the elegant appearance of the ship. The people responsible for maintaining the electrical supply worked behind the scenes. Electricians and engineers monitored voltage levels, inspected equipment, and responded to technical issues. Their role was essential to keeping the ship illuminated and operational around the clock. From a technological perspective, Titanic represented a major step forward in maritime engineering. Earlier ships relied heavily on mechanical systems and limited lighting, but Titanic embraced electricity on a much larger scale. It functioned almost like a floating city, powered by its own internal electrical infrastructure. Looking back, the electrical distribution system of the RMS Titanic reveals how ambitious the ship truly was. Designers wanted passengers to experience comfort, reliability, and modern convenience while traveling across the ocean. It also reminds us that technology often operates quietly in the background. Passengers could walk through illuminated halls without ever seeing the generators or cables that made it possible. Yet every light, every signal, and every powered system depended on that hidden network. More than a century later, Titanic's electrical system remains impressive for its time. It combined steam power with electrical engineering in a way that reflected the rapid technological progress of the early 20th century. In the end, the electricity supplied across the RMS Titanic was more than just power. It was the energy behind the experience, the invisible system connecting every deck, the force that kept the ship alive day and night, and hidden beneath the luxury and steel. That electrical network powered one of history's most famous ships through light, motion, and innovation.